What is the definition of Young's modulus? Yeah. Young's modulus of elasticity equals stress over strain. Or if you want to write it out more in words, the ratio of stress to strain. That should do it. It's only 1 mark after all. Okay. Young's modulus equals 2 times 10 to the 11 pascals. Calculate the extension if the length is 2 meters, the diameter equals 1.5 millimeters, so the radius would equal 0.75 millimeters. And there's a weight, the force pulling it down is this 15 kilogram weight. So the force would equal mg. So that would be 15 times 9.81. So 147.15 newtons. Okay, so it looks like we have all our information here. And we're looking for the extension. So, what's our... You need me to go back? Oh, this part? No.
Is it R equals O?
Huh?
R equals O.
0.75, yeah. Is half the diameter.
Is it R?
Yeah, that's an R, yes, sorry. Okay, so Young's modulus, the formula for that? Stress over strain. Now, what's we have to put in what stress and strain is. So what's the formula for stress? Force over area. And strain? Delta L over L. Now let's look at what we know. Do we know Young's modulus? We do. Do we know the force? We do. Do we know the area? We could know it because we're given the radius here. The area would just be pi or squared. So we know that. We know this length here, and we want the delta L there. So let's put in the numbers. So we have 147.15 divided by pi 0.75 times 10 to the minus 3 squared. Clean that up a bit for you. 147.15. I'm just going to bring this up to the left. Equals delta L over L multiply Young's modulus. Now, what's nice on the right is that they cancel. So you can get the delta L out with not too much difficulty. So I got from this equation delta L equals 0.83 millimeters. Okay. B part, you see you have the diagram there, and they want you to calculate the x. So we've seen these type before. Where would be convenient in that diagram to take the turning point? I think the support rod. So if I was to look at this, that first force, the 250, is that clockwise or anti-clockwise? Clockwise. No, anti-clockwise. So it's 250 times 1. And then what about the other three forces? They're all clockwise. So we have the weight, which is 50 times its distance, plus 80 times its distance, plus x times its distance. Now, look at the diagram. We're told that this rod is 4 meters long. So who can tell me the distance from the support to the weight? No? No?
It's 4 total up.
Yep.
2 is a side.
Oh, you're right, sorry Andy. Yeah, it is 1. So the distance is 1 then. And then how far is it to the 80?
2.
No? Yes, sorry. I'm having a bad morning. 2. And then finally, how far to the x? 3. Actually, if you look at the diagram, they've done it nicely for you. Each of these is 1, 1, 1, 1. So, that's good. Alright, so not too difficult to get the x from this. 250 minus 50 minus 160 divided by 3. So there you go. I got x equals 13.3 newtons.
This is a material question.
Funny enough, in both the physics book and the exam, they like to put these turning force questions in the material question. Okay. Next one now.